Hey guys, it's been a while since I've actually updated anything. I haven't done much because my Viridia controller is still on the ocean coming from China. I did take off my cover. I got tired of building a ship in a bottle. So my cover's resting over there so I can actually get to both sides of everything. Went out and bought me some really nice fat zip ties that fit the slot that Rob put in the holder. Thought that'd be nice. I've got my my first mirror mount in there. Everyone seemed to have a problem getting that mounted, so I got that all put in to match up with my other second mirror. I happen to have my mirror is on a piece of 3D printed plastic on my MPCNC. Once I get everything moving, the MPCNC will no longer be a laser. So I'll pull that off and finish mounting it over here, and this will become my only laser, which would be kind of nice. I did get my 10 centimeter by 10 centimeter drag chain on the y-axis. I've got my air tube and my Z-probe wires coming out, ready to hook up to something. And then I'm still battling this limit switch. This is perfect to stop it right before the end of the table for my zero mark, but the mechanics, oh, I think it's moved now. Where I had it originally, it would run into this bolt down here. So I'm still working on how to get that mounted where it works right. Then I got the big 15 by 10 cable chain, and it has the stepper motor wire pre-run. This is more 18 gauge for conductor. The only trick with this one was that this particular cable chain, while it does try to hold itself up, it doesn't do a very good job. So I wound up needing a little bit of an aluminum angle bracket to run in there to keep it from drooping all over the place. But, you know, it's something. And like I said, my Viridia controller's gone, so I have one of these STEM Arduinos built into a breadboard, fun for all kinds of projects. So I dug it out and I connected it up to my 542 driver and my 24 volt stepper power supply. This is a separate supply I got just for the steppers. And I wired it up to my mains and put it on a safety switch. And now, what I can do for fun is, if you watch my, here I'll move this out like this, and I'll reset the Arduino board. So it goes back and forth 10 times, stopping for 1 second before changing direction, so I don't actually, you know, freak out the motor. It's not real acceleration savvy. It's a quick little for loop, but it does show me that my axis works. My motor barely gets warm, and I'm on the, I think I'm on the setting. Let's see, we get all kinds of settings here. I think I chose the 1.46 amp setting in this case. The motor requires 1.7 amps, so I didn't go to the 192 yet. So I'm running it cold. It's warm to the touch, but only warm as in like a warm cup of cocoa, not a hot cup of McDonald's coffee. So this is, I could wrap my hand around this and hold it there all day. Might feel pretty good. If I was feeling sick, this would be a nice little warmer, but it is by no means hot. Anyway, so that means I got the tension right. That little fast jog back and forth didn't skip at all. And, you know, guys, I got to see motion. So now I'm going to move this to my x-axis and see what happens. See if I can get the whole gantry to move, and then I'll go to the desk or the Z table. Obviously, I'm going to fix the timers so they're not doing a 100 millisecond delay between steps, so it's not trying to move super rapid. I mean, I could also go through, I left the steps default on my driver, and so it's like really geared down. I think it's 28,000 steps per revolution or something that it has available to it. And I don't think I want to run that fine. So if I were to change the steps and have less steps per revolution, the current loop that I have right now goes 4,000 steps. That would probably crash me into my motors, or throw this thing onto the floor, and I don't want to do that. So I really, honestly, I'm tired. I've done a little bit of working. Oh, I've got my grid. And this is my 1/4-inch grid for my Z table. I mounted it to 2 bars that were sized just a little under this, so I still have some slop if I've got to adjust it. Screwed it down with aluminum plate on top, and then on the other side over here, I have a little turnbuckle using these guys with a long screw that's all the way through, and I can pull that taut on both sides. When I did, it worked really well on the edges. I couldn't bounce much, but I needed these on the side as little mini turnbuckles to pull it taut in the center. So as you can see now, I've got all my tools on there, and it is not bending down to touch the channel below it. So that's taut enough for me to put 6 and or 3 and 6 millimeter plywood on for me to cut puzzles. For me, I need the really tiny grid spaces, because I can't have the puzzle pieces falling through like you would if you were cutting out holes in a really fancy lattice design. Usually the things you cut out, it's okay for them to fall through like a nail board or a knife board, and they can get blasted by the laser and turned into pulp, but you don't care. It's the piece of wood that stays on the board that you want to keep. When I'm doing puzzles, it's the exact opposite. Every little piece that I cut is a precious piece, because it's got somebody's picture on it, and the last thing I want to do is have it come off the table in any way and get charred. So this is going to be my first run at a bed. The next thing I'll have is I'll have a lay down in nail board. I'm going to go get a 2x4 foot piece of MDF and put a thin piece of aluminum sheet metal over the top, and use my CNC once it's back together to drill me a pattern of holes that I can put the nails in, and the nails will fit this grid, and then I can put the grid over the nails and have the best of both worlds, a nail board and a grid for my puzzles. Well, that's kind of all I've done so far, guys. It's been fun. These belts, I'm not sure exactly how tight they need to be. I don't have them real tight right now, but I'll work on that once I see it move.